All right, perfect. So we are good to go. So what we're going to be doing today is we're going to continue on with our look at Chapter 8. So we took a look at the single sample t-test last time. Today we are going to continue on with our look at the dependent means t-test. So another situation that oftentimes occurs in psychology, even more so than the single sample t-test. So we're going to see one small little tweak that we need to make in order to run this hypothesis test. But before we get to that, we are going to take up exam number 2 at this time. So that was exam 2. So hopefully after this take up, if if you did not get perfect on these scores, exactly what did happen and where it happened. So we're going to just wrap up just a little bit before we begin our new stuff for today. So just a wrap up of exam number 2. So one thing to keep in mind as we go forward is that this entire course is a process. It's a program that I basically developed to take everyone who has met the prerequisites and bring them along to a point where they can do statistics by the end of the course. So for some students it happens early, for other students it happens later. But I always kind of find it interesting to take a look at how the performance changes from exam to exam. So here we have a frequency distribution showing how everybody did on exam number 1. And as you can see, it was pretty widely distributed. Some students, like I said, get it from day 1. Other students struggle with it at the beginning. But very gratifyingly, for those of you that are doing the program, it's changed. This is exam number 2. So you can see very few people are struggling as much as they did before. We have way more scores here in the 90s and the 100s. We got way more scores, in the 80s, in the 70s and the 80s. So this is just kind of proof that it's working. Scores are being brought up. Understanding is getting there. And it is my experience in this course that this trend continues on through exam 3 and exam 4. So just keep that in mind as you're going through. If this is you, again, right now, keep doing what you're doing. You're doing great. It's exactly where you want to be. If you're in here, chances are you missed one entire question or maybe one complete aspect of hypothesis testing. So make sure that you know exactly what went wrong. If you didn't know how to formulate a null and research hypothesis, make sure that you go back and review that. If you didn't know how to make that final decision, if you got those backwards on accepting or rejecting a null hypothesis, make sure that you get that done correct. And if you are still down here, still majorly struggling, that again is an indication that something is missing. Some core aspect or core understanding of what we've been building on is still not quite there. So if you need to, come by my office hours. I actually have a new automated appointment program that I'm using. There is a QR code and a snap code on my door. You can just schedule yourself a meeting. You don't need to, you can just drop by, but if you want to guarantee availability, feel free to do that. But definitely, there is still time to turn it around. So remember that your lowest exam and your second lowest exam are worth very little of your final grade. So if you're still struggling, there's still time to turn it around. Come by an office hour, let's make sure that we do it, because we are now moving into an entirely new area. SPSS uses the old understanding, but is a great opportunity to turn this all around. And on that note, off we go to the new stuff. All right, so just to remind anybody who might have, I don't know, maybe come in late last time or not seen the YouTube videos yet, just to make sure that everybody's on the same page, you do have access to SPSS for free. So please do not be subscribing or paying any subscription fees. You have that available through IU Anywhere, not IUware. IUware is where you can download programs to install on your computer, and I highly recommend you take advantage of that. The subscriptions and the licenses have been paid for you for the ones that you have access to there. But for anything else, that you need, IU Anywhere is a great resource as well. For this course, SPSS is available in IU Anywhere, so you can do your homework from home. However, make sure that you try it out. The Citrix installer that you are required to use sometimes has a few idiosyncrasies, so just make sure that you get that all squared away. And if you have issues with it, take it to the IT help desk here at IUSB. They're now in the Education Arts Building, and make sure that you get all that handled so that you can do all this work in the comfort of your own home. All right, so what are we going to take a look at today? We are going to take a look at punishment. So punishment has long been used as a method of behavioral change. And what psychologists have done who have studied punishment is they have found that if you're trying to discipline a child and you're trying to change the behavior of your child, spanking is actually not very effective. It's not a great way to change the behavior of your child, and much more effective with fewer side effects is the timeout procedure. So whereas it used to be common practice that children would get spanked for transgressions, nowadays it's way more common that they're just simply placed in timeout. You go to your timeout chair, you face the wall for however long is required, given your age and development. Some psychologists wondered if timeout is effective for children, can it also be effective for adults? And does the duration of timeout matter when you are an adult? Is it more effective if it's longer or if it's shorter? So that's the study that we're going to take a look at today. Is timeout effective for changing an adult's behavior? So for that, we're going to have to introduce a new hypothesis test, a hypothesis test with dependent means. And then we're going to take a look at how to do this new hypothesis test in SPSS. We're also going to introduce a new way to do step 5. And what this is going to do is it's going to allow us to do the entire hypothesis testing procedure without going to the textbook. We are going to be able to do everything by reading data and output from SPSS rather than having to go to the textbook, go check that t-test distribution table. We're going to be able to cut that out, and we'll show you how to do that today. And then also mention the homework assignment and the extra practice that you have to practice this SPSS. All right, so let's take a look at this demo problem for the t-test with dependent means. So I'll read it off to you just real quick. So placing children in timeout can be an effective form of punishment. Research suggests that the same technique can also be effective for adults. So that was a study done in 2007. In the study, participants were shown a series of colored shapes and had to classify each stimulus into one of two categories. Each correct response was rewarded with a nickel, and each incorrect response was punished by a timeout period of 5 or 10 seconds. During the timeout, no stimulus was presented and the participants had no opportunity to earn more nickels. The dependent variable was the overall level of accuracy during a series of trials. Assume that each participant completed a series of trials using a 5-second timeout period and another series using a 10-second timeout period. Data for a sample of 9 participants are as follows. So we're going to do a two-tailed test with an alpha 0.05, and there is your data. So participant A, the first subject, the first participant, they participated in the 5-second timeout condition, and they scored 71% correct. They then also participated in the 10-second timeout condition, and they scored 86% correct. Participant B participated in the 5-second timeout condition, got 68% correct. Then they also did the 10-second timeout condition, got 80% correct. And we have scores for all 9 participants here. So this is a new situation. This is the first time that we're measuring subjects twice. And because of that, we need to change up the way that we do our t-test slightly. So this measuring subjects twice is actually a very, very common way of doing studies in psychology, especially if you're testing the effectiveness of treatment. So anytime that you do a study where you measure people before treatment, then you give them the treatment, and then you measure them after treatment, you are doing this design, this dependent means design. So anytime you measure subjects in one condition, for example, before treatment, and then you measure them in another condition after treatment, this is the design that you use. And if you recall, this is the design that we should have used on that self-esteem study for that elementary school. And remember, we only measured the students afterwards, and I had to point out that that's a very artificial thing to do. It's as if we just forgot to measure their self-esteem before. Of course you're going to measure their self-esteem before, then give them the treatment and measure their self-esteem after. Well, that's what we're going to be doing today. So we have a sample from an unknown population, pre-treated sample, for example, and then we measure the mean of that, the raw scores for that sample before the treatment. Then we treat them and we measure them after the treatment. That's the new characteristic. That's the new aspect of this. We measure them before treatment and we measure them after treatment. And what we want to know is we measure them before treatment. This is when they belong to the untreated population. We know that because we just took them from the untreated population. What we want to know is that after we treat them, has our treatment changed our sample into a sample that now belongs to a new population, to a treated population? That's the question that we're asking here today. So just again to give you a little bit of background on why this is being included in the same chapter as the single sample t-test that we looked at last time. The reason that it's included in the single sample t-test is that when you do this t-test, in essence, what it boils down to is you getting a different score for every single subject. All right, you doing 5 seconds minus 10 seconds here for every single subject, and then you using this different score as your single sample and comparing it to comparing this mean difference to your hypothesized difference of 0. So if we really wanted to, we could reduce this entire hypothesis test to a single sample t-test that compared our differences to a hypothesized mean of 0, a hypothesized mean of no difference. However, that's kind of why it's included in the same chapter, but we don't need to go down that route because we're going to see how to do this all with SPSS. So luckily, very nicely, same 5-step procedure. New hypothesis test, same 5 steps, so let's go through those steps right now. Step number 1, we're going to restate the question as a research hypothesis and a null hypothesis about the population. So what we want to know is there a difference between the accuracy in the 5-second condition and the 10-second timeout condition? Does that difference in time make a difference in their accuracy? So that's what we're looking at. We need to rephrase it in a way that we can test statistically. We'll do the research hypothesis first. The research hypothesis is the question that there is a difference. There is an effect. It does make a difference, the time differences. And we write that as the mean accuracy for the 5-second condition does not equal the mean accuracy for the 10-second condition. Maybe 5 seconds is higher, maybe 10 seconds is higher, we don't know. But if time in timeout makes a difference, then there should be, they should not be equal. The mean accuracy should not be equal. So that's the research hypothesis. The two of them, the two population accuracies are not equal. If that's the case, then your 10-second timeout sample belongs to a new population with a new mean accuracy. If it's the case that those two are different, then your 5-second sample gets changed into a new sample that belongs to a new population when you put them into the 10-second timeout condition. On the other hand, the null hypothesis is that there is no difference in accuracy. That is saying that the mean accuracy for the 5-second population is the same as the mean accuracy for the 10-second population? If so, then the 5-second and 10-second samples both belong to the same population. The 5-second and 10-second samples both come from the same population with the same population mean. So that's the step 1 done. Step 2, determine the characteristics of the comparison distribution. SPSS will calculate this for us, so we are going to, once again, just kind of make a note of where to find all this information. So let me get that set up as we kind of go through. So we are going to take a look at where we find step number 2. So I'll mention where we get the mean, the estimated standard deviation, and our degrees of freedom. Step number 3, we are going to see where we can set a cutoff sample score or a critical value. So the critical t-score, SPSS will still help us for that, but it will not do it on our own, but it will help. But what we're going to do is we're going to change this to a different way of doing it, which is instead of setting a cutoff sample score or cutoff critical value, we're going to set a cutoff probability. And the way that we do this is by using the probability that's given to us, and our cutoff probability is our alpha level. So the reason we can do this is because probability and t-scores are directly tied to each other. That's why we can have a table of probability and t-scores. So when we look up a t-score for a two-tailed test, basically what we're saying is if our alpha is 0.05, for a probability of 0.05 in the two tails, what is your t-score? What is your critical t-value if we put 5% in two tails? That means that percent is directly tied into t-scores. T-scores and percent are interchangeable. It's like pounds and kilograms, right? It's like inches and centimeters. They're directly tied to each other. What that means is that we can do this entire hypothesis test not by comparing t-scores, but by comparing probabilities. And once we make that shift, then we can do it all simply from the output that SPSS will give us. So that's what we're going to move forward with here. That's the way we're going to do it in the exams. Just a heads up, your homework will still ask you to find your t-critical value, so you're still going to need to go to the table. But let's start doing some real-world stuff here as well, preparing you for your future in psychology. And we're going to start using this cutoff probability instead of that cutoff score. So cutoff probability, where'd you go here? That is your alpha score. So we can already pop that in. It's 0.05 that was given to us in the question. Cutoff probability done. All right. Step 4, determine your sample score on the comparison distribution. SPSS will do this for us. So step number 4, we're going to still compare our cutoff score on our on our comparison distribution, but we are also going to start determining our sample's probability, right? So not just our sample's score, not our cutoff score, but our sample score on the comparison distribution. We're going to start determining our sample's probability. And once again, we can do that because if we have our comparison distribution and we find our sample score on that comparison distribution, that ties in directly to our sample probability, right? That ties in directly to the size of that tail, which is your sample's probability. So instead of comparing sample score to cutoff values, we're going to compare sample probability to cutoff probabilities. It's the same logic, it's the same move. It's literally saying, instead of comparing kilograms to kilograms, we're going to compare pounds to pounds. It's the same move. It's the same idea. It's just that this information is given to us in SPSS, so we're not going to have to open our textbooks, and that is really the way that you do it outside of an introduction to statistics course. All right, so we're going to see that today. Hopefully it'll make more sense. That cutoff, that probability of your sample, that is your p-value. And you can see how important that is because it literally gets the designation for probability. So that's what we're going to be looking for step number 4. And SPSS, very nicely, will do that for us. All right, so it's time to do steps 2 to 4. So for that, we're going to go back to SPSS. So if you haven't already, go into IU anywhere, open up SPSS, let's get that running. Also, if you haven't already, open up the Excel sheet for today's class. And as always, in the lecture notes, we have screen grabs, clearly from a while ago, but still works for the way that we're going to be doing things. But also, you'll have this available on the YouTube videos, so you can follow along there as well. All right, so we got SPSS. So we have SPSS open right now. We're ready to go. So what we need to do first is we need to start transferring in our data. So we have our data right here. And just a reminder that if you are going to use SPSS, you absolutely need the raw scores for each participant. Not just the means and the standard deviations, you actually need the raw scores. So we got the raw scores here. So that's good, we can go ahead with this. So the first thing that I want to do is we're going to take the labels for the subjects and we're going to copy and paste that into SPSS. So let's start off with that. So we have our subjects labeled A through I. So let's go back to SPSS here and we'll paste that in. And you'll notice that SPSS has once again named this with a great name if you're a robot, var 0001. You'll remember that if you are a robot, but we are humans, so we are going to go down to variable view here. So at the bottom of your screen and the bottom left, we're in the data editor, the data view. We're going to go to variable view, and let's just call that person, and we will name that person. So that's the label that we used for each participant. I'm doing this right now for 2 reasons. You don't have to do this to actually do the hypothesis test. I'm doing this for 2 reasons. Number 1, if you look at the next column, you'll see that it lists the type of variable that you're dealing with. SPSS tries to guess what sort of information you're giving it, and it'll try to guess what sort of type of information, and typically it's either going to guess that you're giving it numeric information, so you're giving it numbers, or you're giving it string information, you're giving it words. So what SPSS did automatically is it took a look at this data that we just entered in, and it said to itself, you know what, that's a whole bunch of letters. I bet you they're trying to give us words, right? They're giving us a variable that's a string variable. That's the computer programming term for a word. So SPSS figured, oh, they're giving us a whole bunch of word labels. Once SPSS makes that decision, it sticks to that decision for your variable. So in this case, it's going to treat these as words. And if we replace them with numbers, if we say instead, oh no, I want to do this 1, 2, 3, 4, 5 instead of A, B, C, D, E, you'll notice that SPSS doesn't care that you've made that change. It's going to keep it as a word. So SPSS right now is thinking that I mean the word 1, not the number 1. I mean the word 2, not the number 2, and it will not allow me to do things such as add those, take the average of those, do any sort of mathematical operations on these string variables. So that's going to become important because occasionally, and don't do this, but I'll do it first, occasionally people make a mistake when they're transferring in their data, and they might highlight the header instead of just highlighting the raw scores. And if you pop this into SPSS, SPSS will try to guess what is it that you're trying to give it. Are you giving it numbers or are you giving it words? And it'll take a look at that first one there and it'll say, oh, that's a word. And if you're giving it one thing that's a word, it's going to assume that everything is meant to be a word. And you can see it's decided that it's a string. So in this case, you might say to yourself, oh no, that's not at all what I wanted to do. I wanted to put in scores, not words. Let me fix that. Let me get rid of all the words. We just got rid of all the words. SPSS doesn't care. It's already made that decision. You've given me a list of words, not a list of numbers. So the only way, if you make that mistake, the easiest way, it's not the only way, but the easiest way to fix this mistake is to just highlight the entire column, click on the column, hit delete, and recopy the correct numbers into SPSS. So again, SPSS will make that decision on the first paste into a column, and if you mess it up, the best thing to do is to go back, copy it one more time, and paste it in. So this time, let's go ahead and copy it. This time, we're going to copy it. So we highlight the accuracy scores for 5 seconds. Go back to SPSS, paste that in, and this time, notice SPSS has made a different decision. This time it said, oh, you gave me nothing but numbers. I think you're trying to tell me a whole bunch of numbers, and it's decided that it's a numeric variable. Because of that, SPSS will be able to calculate the average for this variable. All right, so now that we've done that, what we want to do is we want to change this var 00003 to something that makes sense. And to me, my human mind, I would want to label this 5 seconds, right? Because we did, this is the 5-second timeout condition. Why not name this 5 second? But SPSS has different ideas. SPSS will say, no, that variable name contains an illegal first character for whatever reason. Because SPSS is stacked on code from the 90s, it does not want that variable name to start with a number. So we're going to use a little human ingenuity, and we're going to say, all right, instead of 5 seconds, how about second 5? Right? That's enough to my mind to recall that this is the 5-second condition, and that's good enough for SPSS because it doesn't start with a number. So whenever you're starting to learn how to do SPSS, SPSS will go rogue on you sometimes and not allow you to do things that you sort of feel you should be allowed to do, like start a variable name with a number. Just read the warning box that pops up, the message box that pops up, make the required adjustment, and you'll be on your way. All right. So we have a column for person. We have a column for the 5-second condition. Is everybody with me so far? Okay. Now we have a decision to make. We have to figure out where to put the data for our 10-second condition. This is part of learning how to format SPSS correctly. So when we go back here, we seem to have two possibilities. We could either paste it right there in the third column and have that as the place where we put our 10-second condition scores. Or we might copy and paste them directly underneath the 5-second condition scores and then have a third column here that labels which group or which condition each of these are. So this would be the 5-second condition, this would be the 10-second condition. Both of those are logical possibilities. Only one of those is correct. And the easiest way to remember how to format correctly in SPSS, especially when it gets into the more complicated hypothesis tests, is to just remember the simple premise that every single row in SPSS belongs to one and only one subject. So subject A, whatever scores subject A has to go into row 1. That is the only row allowable for subject A. Subject B only gets row 2. Any scores for subject B has to go into row 2. Subject C has to go into row 3, and so on and so forth. So with that in mind, the only place where we can paste those scores for the 10-second condition is in column 3, so that we have all of the subject A scores in the first row, all of the subject B scores are in the second row, all of the subject D scores are in the third row. And then the last thing we're going to want to do is we're going to want to go to variable view, and we're going to want to change this var 00004 to second 10 to indicate that it is the 10-second condition. And that is the proper setup for this dependent means t-test. Is everybody at that point? All right. I'm going to start asking if anybody is not at that point, or if anybody's arms are super tired. Okay, so we're all ready to go. We got it formulated. We go back to analyze. We go back to compare means. Remember, all of our tests are in this file drop-down. Analyze, compare means. And whereas the single sample t-test was very friendly, so we wanted a single sample t-test, and SPSS says, I got a one sample t-test, which is very friendly to us. When you look for dependent t-test, you don't find one, right? There's nothing here that looks anything like dependent. There's independent, we'll get to that in chapter 9, but there's nothing here that looks like dependent. And the one that we want, this is when SPSS is not being friendly, the one that we want is that paired samples t-test. So make a note somewhere, your dependent means t-test is your paired samples t-test in SPSS. That's the correct choice for the paired samples t-test. So we click on paired samples t-test, and we bring up this dialog box here for paired samples t-tests. And then the last thing that we're going to do is we need to let SPSS know who's variable 1 and who's variable 2. So when they're comparing these two scores, which one should we be subtracting from which other score? And honestly, I can never remember which one gets subtracted from the other one. So I'll show you what to do to kind of deal with that. But the first thing to realize here is that, look, we have the variable scores for 5-second condition. We have as an option the 10-second condition, but nowhere is person listed. SPSS will not allow you to choose that for a paired samples t-test. So if you get to this place and one of your variables is missing, that's SPSS telling you, I think that variable was a word, so you don't even get to include it here. So what we're going to do here is we're going to click on the 5-second condition. We're going to pop it in using the arrow, and it goes into variable number 1. We are then going to take a look, click on the 10-second condition, pop that in using the arrow. That puts it as variable number 2. So now we have these two variables put in here. And if we want to change the order on these, this little bidirectional arrow here will do it for us. So what I typically do on this is kind of like trying to plug in a USB. You don't try to figure it out and then plug it in. You just try it, and if it doesn't work, you flip it and you do it again. Same thing with this paired samples t-test. Try it. If it turns out that it's not subtracting them in the order that you want, just go back here, flip them, do it again. It's pretty simple. So let's try it with seconds, 5 seconds in the first variable, 10 seconds in the second variable. We're all good. We're ready to go. We hit OK. And SPSS runs our paired sample t-test. All right, so let's interpret. So we have our paired samples t-test. Now what we need to do is we need to find all of this information, and we need to make our final decision. So for this, we are eventually going to get to step 5 here. So step 5 is also going to change slightly now. So in your homework, and you can still do this way elsewhere, we still stay with the same logic. If your sample t-score is beyond the cutoff t-score, you accept the research hypothesis and you reject the null hypothesis. If, on the other hand, the sample t-score is within the cutoff t-score, you accept the null hypothesis and you reject the research hypothesis. We're still going to be using that logic, but we are going to be swapping out probabilities for t-scores. So the new rules are that if the p-value, if the probability of your sample is less than your alpha, less than your cutoff probability, you accept the research hypothesis and you reject the null hypothesis. If, on the other hand, your p-value is greater than your alpha value, your sample probability is greater than your cutoff probability, you accept the null hypothesis and reject the research hypothesis. It's the exact same logic, much like before, until this makes absolute sense to you. Use these two slides to help make your decisions. All right, so let's start taking a look at this. Let's start breaking it down. Let's start figuring out where to look on this t-test output. So the first thing we want to do, and always do this, check your descriptive statistics and make sure that you've entered in your data correctly. So for example, we know what the means are from our Excel sheet. We had the means calculated in our Excel sheet. SPSS also calculated the means for the 5-second condition and for the 10-second condition. So compare those. Just make sure you didn't have a copy and paste error. Those means equal the ones in Excel. That's an indication that we entered the data in correctly. We can check how many scores are in each condition. We got 9 scores in each condition. We have 9 subjects in this experiment. SPSS is just letting us double check, once again, that we've entered in everything correctly. So it's always a good habit to just take a look at that, make sure that you've entered in the data correctly. Next one, determine the characteristics of the comparison distribution. SPSS will do this. Yes, it will. So we have, we need our degrees of freedom, we need our estimated standard error, and we don't need the mean, but I'll show you where you can get that as well. So we'll start off with the, what did I start off with? We'll start off with the estimated standard error. For this one, make sure, actually for all of them, make sure that you are making notes about where to look in the output. Because notice, we have standard error of the mean up here, and we got 2 numbers. We have standard error of the mean down here, and we got 1 number. We got 3 numbers up there that are all labeled standard error of the mean. Which one is the one that we want? Is that one right there. So make a note. It's in the paired samples test, paired differences table down here. That's our standard error of the mean. We got 2.00 for the standard error of the mean. For the degrees of freedom, a little bit more friendly on that. Degrees of freedom is right there. We got 8 degrees of freedom. And you're not going to see the comparison distribution mean anywhere on your SPSS output. The reason for that is that for a dependent means t-test, your comparison distribution mean is always equal to 0. So you're not going to see it output anywhere because it's just always equal to 0. All right, so step 2 done. Step 3, set a cutoff sample score or critical value. SPSS will not do this for you, but it will help. So once again, it helps us by giving us that degree of freedom, those 8 degrees of freedom. So for the t-critical, we have to go back to our t-distribution table. We are doing a 2-tailed test. We have 8 degrees of freedom. We got an alpha of 0.05. There's your critical value right there, plus or minus 2.306. Or instead of that, tediousness, we can use our cutoff probability, and the cutoff probability is your alpha score, and that is given to you in your question. So it's up to you which way you want to go. I like using the cutoff probability scores because it's all in one. You don't have to go to the table. All right, moving along. Determine your sample score on the comparison distribution. SPSS will do this. So once again, or we can have our sample's probability on the comparison distribution, which is our p-value. SPSS does both of these for us. So where do we find this information for step 4? Well, for the t-statistic, we go down here. It'll indicate what was subtracted from what. So we have the scores in the 5-second condition minus the scores in the 10-second condition. That gives us a t-statistic. Sorry, that gives us a difference of 7% between the 2 means. That gives us a t-statistic of minus 3.5. If we were doing a 1-tailed test, for example, and this was in the wrong direction, that's when you go back, just switch it up, make it easy on yourself, and just rerun that test. As it is, we're doing a two-tailed test. It's fine either way. Cutoff score, our sample's critical score, our sample's t-score is 3.5. That's associated with a probability, a p-value, right there of 0.008. So our score, our sample had a t-score of 3.5. That is associated, that is linked to a probability of 0.008, right? So that is 0.8%. So what we do now is we're going to wrap all this up since we found all our information, and we're going to decide what to do. And the thing to notice here is that the decision you make with the sample, with the t-scores, is the same decision you'll make with the probability every single time, because the two of them are directly linked. So look at this. If your sample t-score is beyond the cutoff t-score, our sample t-score is minus 3.5. Our cutoff score is minus 2.306. Our sample t-score is beyond the cutoff t-score. What do? We're going to accept the research hypothesis. So our final decision is going to be accept that research hypothesis. If it was the other way around, if it was within, then we would accept the null hypothesis. All right, we've already seen that. So our cutoff score is beyond our critical score, our sample score is beyond the critical score. We reject the null hypothesis, we accept the research hypothesis. If we didn't want to use the table, we use this decision. If your p-value, your sample probability, is less than your alpha, what do? You accept the research hypothesis. Look at that. Same exact decision. So you can do it either way. If you want to go to the table, go to the table. If you don't have the table available, you can do it all through SPSS. If the opposite was true, we would accept the null hypothesis. As it is, our probability here for our sample is less than our alpha value. So we reject the null hypothesis, the exact same decision. And that's why we can substitute one in for the other. And we now know that timeout does work on adults, and people in the 10-second timeout condition were faster than they were in the 5-second, were more accurate than they were in the 5-second timeout condition. All right, we made it. Sticking in an exam take-up sometimes pushes us to the limit here, but we made it to the end. So just a reminder, continue to do the MyStatLab study plan. Try to pick up those points as we get more challenging with our pre-test. Unfortunately, we don't have any extra practice time available today, but there are extra practice opportunities in the Excel sheet. You got the raw data in this PowerPoint, supplemental slides. You have the questions. You have the SPSS output that you should get. And then you have the solutions for each of these steps, including your p-value and your alpha value solutions, so you can start practicing doing that. And just so you know, you are now ready to do your homework assignment chapter 11, homework assignment number 11, chapter 8, homework part 2. That's going to be due November 11th. So I believe is that Monday or not? It is? Yeah, okay. It's been one of those weeks. So that's on Monday. So one last thing, I highly recommend, get used to SPSS, use it for your homework. That's why you have that IU Anywhere access. So you can access it from anywhere, but make sure that you get very facilitated with that, very experienced with that, because SPSS is what we're using for the rest of this semester. All right, that is it. So that's all we're going to be covering for today, and I will see you all next week.